Hello everyone, I'm Wei Qing from NUAA China. I'm very glad to introduce our work in the journal First Track of ICSI. My topic today is smart contract development, challenges and opportunities. Smart contract was originally coined to refer to the automation of legal contracts in general. Recently, it's popularly used to refer to low-level programs running on a blockchain, and we also focus on the latter specific definition of smart contract. A smart contract program can be automatically executed when certain precondition is met. This is a smart contract written in Solidity programming language. It defines some cell behaviors using buy and sell functions. As shown in the right picture, there are a list of blockchain platforms which support developing smart contracts, including Ethereum, Neo, Corda, and so on. Our study mainly focused on the Ethereum platform, which is the most popular public blockchain platform for smart contracts. The self-executing nature of smart contracts provides a tremendous opportunity for use in many fields. More and more developers and researchers are devoting themselves to the new area of smart contracts. Despite the increasing popularity of smart contracts, the potential challenges that developers are facing when developing smart contracts have not yet been clearly explored. To help advance research in smart contract development, we conducted a study to explore the work practice and potential challenges faced by developers during smart contract development on blockchains, with a focus on Ethereum. This is an overview of our methodology. Our study includes two parts, the interview part and the survey part. The interview part is to get insights from expert developers into smart contract development, and the survey part is to validate the findings of the interviews. In the interview part, our participants were from both GitHub and the industry, whoever worked on smart contract projects. We sent emails to invite them to participate in our survey interviews and also ask them for help to introduce their friends or colleagues for interviews. Finally, we had 31 interview candidates. For those candidates, we conducted semi-structured interviews through Skype, WeChat, and Google Hangouts. That is, we used some open questions listed in Table 1 to guide the discussion. We also asked follow-up questions to dig deeper into our interview participants' viewpoints when appropriate. We stopped interviews when situations of findings were reached. Finally, we interviewed 20 interviewees and obtained 20 audio recordings under the permission of interviewees. Table 2 listed the basic information of 20 interviewees. Then we performed audio recording transcription, text segmentation, and card sorting on the interview comments. We obtained hierarchical categories of findings. After that, we designed a survey questionnaire to validate the insights that we got by analyzing the interviewee comments. Our survey included both demographic questions and smart contract questions. We sent our survey invitations to randomly selected 2,000 GitHub developers on smart contract related projects and some industry friends. Finally, we got 232 respondents. By analyzing the voting results and the survey comments, we got an overview of the current challenges developers are facing in their smart contract development. We obtained 6 major categories of challenges developers are facing during their smart contract development. They are related to code security, debugging, Solidity programming language, Ethereum virtual machine, gas, and online resource and community support. These are 28 challenges and desired improvements mentioned by interviewees. In the table, C1 to C6 were 6 major challenges on the whole of smart contract development. C7 to C17 were challenges developers were facing during different stages of smart contract development, for example, coding, testing, debugging. I-18 to I-28 represented the desired improvements of Solidity and EVM respectively. The last column is the number and ratio of respondents who voted for the corresponding challenges or desired improvements. For example, for the C1, we found that 71.6% respondents voted that it's hard for them to guarantee the security of smart contracts. And for the brand new programming language and virtual machine, particularly designed for developing and running smart contracts on Ethereum, respondents voted the most desired improvements. For example, the I-18 shows that 53% voters hope Solidity could support or provide more general-purpose libraries. Based on our results, we further summarize some future research directions, such as developing tools to prevent vulnerabilities spreading further, transforming features from other virtual machines and programming languages into EVM and Solidity to make developers' life easier. Okay, this is my talk. Thank you so much for your attention.